A very good afternoon to our lovely grade 12 learners. Welcome once again to Mathematical Literacy lesson. My name is Mampani Kekana, and remember that the lesson is brought to you by the Gauteng Department of Education in collaboration with the Saibono Discovery Center. Now, boys and girls, again, last push, last push, last push. It's now countdown. We are talking about 2 weeks before you can write your maths lead papers. Okay, so I hope you are also studying hard for those papers as well. So our focus today, as part of our last push as well, is going to be on measurement. I'm glad that most of you are now doing good in this topic, measurement. So please just make sure that you keep it up, study more, and study very hard as well. So as I indicated, today we're going to look at measurement, and then of course under measurement, very, very important part is conversion. So in MathsLit, or in this uh, measurement, conversion, it's like a foundation. It's just like when you build a house, you need to start with a foundation. If your foundation it's not good, then the whole house is not going to um, sustain. So it's very important that your conversion is very, very good, because conversion is part and parcel of every section in MathsLit, okay, especially under paper 2. And then of course we're going to look at how we calculate perimeter, and we're also going to look at how we calculate area, and also how to calculate volume. Right, so of course at the end of this lesson you should be able to calculate perimeter, area, volume, and then of course be able to do conversion. And then the second bullet there, it says change the subject of a formula. Now this is very, very important, boys and girls. Change the subject of a formula. Most of you are actually struggling with this part and correctly substituting values into a formula. What do we mean by change the subject of the formula? I saw even in the prelim where learners were given the area, like, okay, let me just put it like this. We all know that the formula for calculating area of any rectangular shape. The formula for calculating area of any rectangular shape is area equals to length times breadth. I know that most of us, we are used to a situation where you are given the length and you are also given the breadth, and then they ask you to calculate the area. But remember, the examiner might also give you the area, might also give you the length, and then they ask you to calculate the breadth. And that is where some of you are having a challenge. If you've got a formula like this one, I can just take you back to that formula of speed, um, time, and distance, where we are using a triangle. In this case as well, we can say if I've got a triangle like this, then I know this is the area. Okay, then for the area it's going to be LB. What does this mean? If I want to calculate the area, the L and B must be next to each other. In other words, I take length and multiply by breadth. That will give me the area. But what if in a case where I'm given the area, I'm given the length, and they ask me to calculate the breadth? What I do is I have to take the area and divide it by the length. What if you are given the area and you are also given the breadth, and then they ask you to calculate the length? Then it must be the area divided by the breadth. The same thing with any other formula. I can think about if you've got a volume. So for a volume, we're going to divide it into 3 sections. So it's length, it's breadth, it's height. And then this one, we know that it is the formula for calculating volume. How do we calculate volume of a rectangular prism? We always say volume equals to length times breadth times height. So that means the length, the breadth, and the height must be next to each other. But the examiner can also give you the volume. They give you the volume, they give you the length, they give you the breadth, and they ask you to calculate the height. And then that is where most of you are struggling with. How do we change the subject of the formula? So to change the subject of the formula, we know that if we have to calculate the length, then we're going to say length is equals to the volume must be on top, and at the bottom we're now going to have B and H. So we're going to have B times H. Okay, I can think of many formulae where you have to change the subject of the formula. Like if we've got again a cylinder, the formula for calculating the volume of a cylinder, we all know that that formula is V equals to pi r squared H. Okay, most of us, we are used to a situation where we are given the radius, we are given the height, and they ask us to calculate the volume. And then in that case, what do? We just do the substitution. But the examiner can also give you the volume and can give you the radius, and they ask you to calculate the height. What do? Or the examiner can ask you to calculate the radius. What do? If they give you the volume, they give you the height, and then they ask you to calculate the radius, what are you going to do? You have to change the subject of the formula. How do we change that subject of the formula? Again, with a triangle. So with a triangle, at the bottom there, I've got 3. So I've got pi r squared, and then I've got h. There I've got v. If I have to calculate height, then I'm going to say height equals to v is on top. Now I'm left with pi r squared. So this will be pi r squared. So that means in order to calculate the height, I have to take the volume and then I divide it by pi r squared. But now, what if you have to calculate the radius? Same thing, same procedure. If you have to calculate the radius, you know that, okay, the radius, I'm going to say r squared equals 2. Then I still have v on top, and then now at the bottom I'm left with pi and h. So it means in this case I'm just going to indicate pi h. Then I'm going to calculate r squared equals to v over pi h. I substitute the value of v, I substitute the value of pi, I substitute the value of the height. Then from there I'm going to have r squared. Okay, let's say after simplifying this, you get r squared equals to, let's say, 50. Okay, let's say after substituting the value of v, the value of the height, and then 3,142, you get r squared equals to 50. How do you find the value of r? Then for the value of r, you're going to say it's equals to the square root of 50. Okay, I was just taking you on board in terms of changing the subject of the formula. What do we mean by changing the subject of the formula? Think about the usual way of doing it, but what if they ask you a question in a different way? Okay, I can think of many formulae where you have to change the subject of the formula. So please go and check this type of questions, because the examiner can actually ask you this type of questions. Then we know again terminologies, glossary of terms. Boys and girls, again, we say this one, please do not go and spend most of your time memorizing terminologies. We've got so many terminologies in MathLit. Maybe there might be about 200, if not less, but at least 200. But now imagine if you have to go and memorize all of them. So it means you're going to spend most of your time memorizing terminologies. We always say, however way you understand it, as long as your answer is relevant, that is what we want. If I say, what do you understand by the word area? Obviously, there are few words that will come into your mind. Please write it down. Okay? Like for instance, an area, I can say it's an amount of space within a two-dimensional shape. Okay, area, it's amount of space within a two-dimensional shape. I'm sure you've got your own way of explaining it, as long as it's relevant. So in this case, I did not write down the terminologies, because I actually want you to look at these terminologies and think of your own way of explaining this. Okay, because in the exam, obviously the examiner might ask 1 or 2, even though we've got 200 of them. Now imagine if you have to spend all the time memorizing the terminologies only to find that there's only one or two. So very important. Just look at the terminology. Ask yourself, if I look at this, how am I going to explain it in my own words? And it is still relevant. And then, of course, we've got capacity. Capacity, you can simply say it's an amount of space inside a two-dimensional shape. Okay, it's amount of space inside a two-dimensional shape. That will also be acceptable. Circumference, we all know what a circumference is. Circumference and perimeter. Circumference is the total length around a circular shape. Is the total length around a circular shape. And then, of course, we've got a diameter. A diameter, if you think about it, it can be a line from the center of the circle to the circumference. A line from the center of the circle to the boundary of the circle. However way you can explain it. You do have a picture, so you can make use of that picture to write down what you understand by that picture. And of course, a length is the measurement, okay, or the amount of space between 2 points. An amount of space between 2 points. And then, of course, we've got the perimeter. Perimeter and diameter are almost the same, but it's just that in a case of a circle, we don't say it's a perimeter. We say it's a circumference. Okay. No, I mean perimeter and circumference. Perimeter and circumference are actually having almost the same definition, but it's just that in terms of a circle, we prefer to use, or it is proper to use the word circumference instead of perimeter. Perimeter again is the total amount of space, the total length around a two-dimensional figure. Remember, circumference, we said, is a total length around a circular shape, or a total length around a circle. But the perimeter is a total length around a two-dimensional shape. And then, of course, radius. Okay, I think in this case I made a mistake. The diameter is supposed to be a line that divides a circle into two equal parts. Sorry for that. A line that divides a circle into two equal parts. But while the radius is actually a line from the center of the circle to the circumference of the circle. Okay, we've got total surface area. Total surface area, think about a total surface area. That is where we take, let's say for instance, we've got a box, and then now you have to take the area of each and every face. Okay, you calculate the area of each and every face, and then you add them together. That will give you a total surface area. So a total surface area is the sum of the areas of all the faces of a three-dimensional figure. So the sum of the areas of all the faces of a three-dimensional figure. And then, of course, we've got a volume. Volume is an amount of space that can be occupied by a three-dimensional shape. An amount of space that can be occupied by a three-dimensional space. And then, of course, we've got the width, we've got the breadth. If it doesn't specify for the width, you can say it's the measurement from one point to another. Usually, it might be the shorter side of a rectangle. So we can also say the width or the breadth is the shorter side of a rectangle. Now, boys and girls, you are not restricted in terms of writing down the definitions. So please find a way of giving the definitions using your own words, as long as at the end of the day, the definition is relevant. I usually say maybe 4 to 5 words. That will be enough, as long as the explanation is relevant. And then this is a reminder with regard to perimeter area and volume. Remember, the units are always important. Please make sure that whenever you are working with perimeter area and volume, you indicate the units. And then we've got, always make sure that the units of measurements are the same before doing any calculations. What does this mean? Let's say you have to calculate the volume, which is length times breadth times height. Okay, that is the volume of a rectangular prism. If you have to substitute here, you have to make sure that the length, the breadth, and the height are all in the same unit. It might happen that the examiner will give you the length in centimeters and the breadth in meters and the height in meters. Now you can see that only two of them have got the same unit. The third one has got a different unit. So you have to make sure that before you do the substitution, all of them have got the same units. Usually the examiner will lead you, will say, determine the volume in centimeter cubed or in cubic centimeters. What are you going to do? You have to ensure that everything is in centimeters. If they say in meter cubed, you have to make sure that everything that you substitute there, it's in meters. We can't have centimeters, we can't have meters, we can't have millimeters in one formula. We must have the values with the same unit. Okay, and then again, with regard to a diameter, if you have to um, substitute a radius and then you can see that a diameter is given, please remember, because I saw this in the prelim exam scripts, that most learners are forgetting to convert the diameter to a radius. So very, very important. If you are given a diameter and you can see that the formula wants you to substitute radius, please make sure that you take the diameter, you divide it by 2. And then always use the value of pi as 3,142, okay? Especially for those learners who are coming from mathematics, you should know that all the way from grade 10, we've been always using pi as 3,142. We don't use the pi from the calculator. We use the value of pi as 3,142. Okay, and then it's when dealing with semicircle. What do we mean by semicircle? Semicircle is like half of a circle. Okay, if you've got a full circle and then they say calculate the area, we know that it must be area equals to pi r squared. Okay, then to calculate the area of the full circle, this will be the formula. But now what if you have to calculate half of a circle? So if it's half of a circle, what you do is you just calculate it the very same way, but you divide it by 2. Okay, very important. The same thing with half of a cylinder. If it's half of a cylinder, we know that if a volume equals to pi r squared h, okay, you're going to use this formula for a full or a complete cylinder. So what do you do after that? If it's half of a cylinder, then you just take this one, you divide everything by 2. That is what they mean by say, when dealing with a semicircle, remember to divide the formula of a circle by 2. This is the circle. This one is just an extra information that I'm giving it to you, that it can also be the same thing in terms of a volume. But if they have to ask you to calculate area of a semicircle, you just take that formula, which is pi r squared, and then you say over 2, or you multiply it by 1 over 2. And then of course, this is just to refresh your memory, but you don't actually have to memorize the formulae. Okay, here we're talking about the formula of a square. How, if you are given a square, the formula for calculating perimeter is 4 multiplied by one side, or you can take all the 4 sides, you add them together. And then we've got a circle. Circumference is equals to 2 pi r, so it means in this one you have to substitute the radius. Or circumference is equals to pi d, so it means if this is d, it means it's a diameter, you need to substitute the diameter there. And then of course with the rectangle, perimeter is 2 length plus 2 width, and then we've got again 2 in brackets length plus width, so this must be only width. So it's 2 open bracket length plus width, and then we close the bracket. Very, very important. We have seen in the past some learners changing this because they are confusing this with the area. They change the addition sign to multiplication. Remember, with a perimeter, this is always addition. If you see the formula is given with addition, you don't change that addition and make it plus. It is, you don't change that addition and make it multiplication. It must always be the addition. If you are given a triangle does not actually have a specific formula. You just add up all the sides. That is how you determine the perimeter. And then of course we've got irregular shapes. Irregular shapes, it's those shapes that do not have specific formula. They don't have specific formula because you can't tell what type of a shape is that, but it is actually a combination of different shapes. Like if you look at this one, if you have to calculate the perimeter and then you have to add up all the sections that are indicated here, all the sides that are indicated here. So like for instance, in this one, as an example, the perimeter is, we have to add this side, and then we have to add this, which is 3. We have to add this, but this one is not indicated. If this one is not indicated, it means somehow you need to determine what the value of this section is. The value of this section, how are you going to find it? If you look on this side, we've got from this point to this point is 3,4. Okay, so it means in this case we've got 2, and then we've got 3. Okay, so it's 3. So this is 2, and then it's plus this one is 3. So the remaining one will be the value. So if it's 2 and then it's 3, it means the remaining part is 0,4, because the whole of this side from this point to that point is 3,4. From this point to that point must be 3,4. Then it's going to be 2, and then you can see that for this part we've got 1. So it's 2 plus 1 is 3. So it means the remaining one is 0,4. You just have to find a way of figuring out the missing, or the value of the value that is missing for that section. If a section is indicated but the value is missing, you need to find a way of finding that value. Okay, we've got 0,4, of course, we've got 5.5, we've got 3.4, we've got 2.5, we've got 2, we've got 6, and then you add up all the values here. You don't miss anything. If 1 is not indicated, try to figure out what the value of that missing value is. Okay, and then of course with formula for area, again, you don't need to memorize the formula. The formula will be given, unless in a case where the formula is obvious or it's very easy or you don't need a formula. Area of a square is side squared. Area of a circle is pi r squared. Area of a rectangle is length times width, or length times breadth. Area of a triangle is half times base times height. Okay, like I said, what is important in this case, you must be able to substitute, because the formula will actually be given. The same thing with an irregular shape. It is also possible that they might ask you to calculate the area of an irregular shape. Okay, like this one. It doesn't have a specific formula, so it means you'll have to divide it. You can divide it however way. So in this case, if I look at this, I can divide it. So if I divide it, I can divide this into this. Then I'm going to get the first rectangle. Okay, and then I can divide this one, and then this will give me the second rectangle, and then of course I've got the third rectangle. So what I've done in this case, I've divided that irregular shape into 3 rectangles. So we know about the area of a rectangle is the longer side multiplied by the shorter side. If I look at this one, it's just going to be 3 times 1. Then if I look at this one, it's 2.5 multiplied by 3.4. The problem might be here. Okay, the problem might be here because we don't know what is this one. But remember, in this case, we said this is 1, and this one was 1.4, I was 0.4. So this one will be 1.4. Okay, so if this is 1.4, we've got the whole of this as 1.4. Let me just write it inside. So 1.4. Okay, then now we have to determine the length of this side. Okay, so if I look at this, I've got 5.5 is the whole of this. So I can say 5.5 from this point to that point is 5.5. But from this point to this point is 2.5. So it means the remaining will be 2. So this will be 2. So then for the area, I'll say 2 multiplied by 1.4. And then this one is obvious, 2.4 multiplied by 3.4. Okay, so this one, what I'm trying to indicate to you is, if you are given any irregular shape, you can actually divide it and figure out what is the shorter side and the longer side of each rectangle in this case, and then from there you can do the calculations. Right, Again, the formula for surface area, again, you don't need to memorize. Okay, if you look at this one, it says the surface area is 2 times length times breadth plus 2 times length plus 2 times breadth and times h. Okay, so we've got 2lb, 2lh, 2bh. So what is important here is you only need to substitute. You need to know what the length is, which is this one. You need to know what the breadth is. So the breadth in this case is also the same as the width, and then also the height and so on. But what is important here is the length, the breadth, and the height must be in the same unit. If they say this must be in millimeter squared, make sure that the length, the breadth, and the height, all of them are in millimeter squared. If one of them is not in the same unit, you need to convert it. Conversion is the basic. So we've got the surface area, which is 6s squared. Okay, that is the area of base. Then you also do the substitution. The surface area, 2 pi r squared plus 2 pi r h. 2 pi r squared plus 2 pi r h. So this one, you need to know what the value of r is. And then please, if I can just write it down, surface area is equal to 2 pi r squared plus 2 pi r h. What is happening here is most of you forget to square there to make it to the power of 2. So make sure that this one is squared, but the second one is not squared. So if this is 3, you're going to say 3 to the power of 2, which is 9. You are not going to say 3 times 2. You say 3 to the power of 2, which is the same as 3 times 3 is 9. So please make sure that the radius that you substitute there is the same as the radius that you substitute. You can't substitute 5 there and then that one you substitute 4, because it's the same radius. So please make sure that you substitute correctly. Right, and then of course the value of pi, as always, is 3,142. The formula for volume, again, I think we spoke about this: length times breadth times height. Okay, the length, the breadth, and the height might also be must also be the same. Also bear in mind or remember that they might also ask you to find the height where they give you the breadth and they give you the length. So you must be able to change the formula. Okay, the same thing with this one. Volume is equals to side to the power of 3. If they give you the value of the side and then they say the value of the side, let's say is 2, then we say 2 to the power of 3. 2 to the power of 3 is not 2 times 3, but it's 2 times 2 times 2. You'll see when you do it on a calculator, 2 to the power of 3, it's going to give you 8. So let us please make sure that we know how to simplify those powers. And then again, V equals to pi r squared h. Okay, this one, when they ask you to calculate the volume, and then remember, I also spoke about it. I said they can also ask you to find the height. So if you have to find the height, it means you must be able to change the subject of the formula. They can also ask you to find the radius. Then you must also be able to change the subject of the formula so that in the end you calculate the radius. They can also ask you to calculate the diameter. Okay, they can also ask you to calculate the diameter, but in this case, if you look at this, the diameter is not given. So what are you going to do? It's just a matter of thinking. You must first calculate the radius. Once you got the radius, then you just multiply it by 2 because the diameter is not in that formula. So it means you'll have to calculate the radius, and then in the end, when you are sure that this is your radius, and then now you multiply it by 2, because we know that diameter is radius times 2, and then we know that radius is diameter divided by 2. So let us check such type of questions, boys and girls. Okay, and then again, with regard to conversion, this one you need to know, you should know it. Okay, kilometer to millimeter, we multiply by 1000. Okay, and then if you convert from a meter to a kilometer, you divide by 1000. From a meter to a centimeter, we multiply by 100. And from a centimeter to a meter, we divide by 100. If we convert from a centimeter to a millimeter, we times by 10. And from a millimeter to a centimeter, we divide it by 10. This one, it's very easy for me because I always think about a ruler. where one edge of the ruler is in centimeter and the other edge is in millimeters. You'll see on the side of the centimeters, if it's 1 centimeter, and then on the other side, it will start with 10 millimeters. It only shows that 1 centimeter is the same as 10 millimeters. And then, of course, with regard to conversion, we all know that a ton, for us to convert a ton to a kilogram, we multiply by 1,000. And then from a kilogram to a gram, we multiply by 1,000. From a gram to a milligram, we multiply by 1,000. But if you convert from a gram to a kilogram, you divide by 1,000. Boys and girls, you need to be sure about this. You need to be very, very sure. I always say this is actually the type of questions where you cannot afford to lose the marks, because this is very easy. But the problem is some of you are not sure whether you have to divide or you have to multiply. Please be sure when to multiply and when to divide. The same thing with capacity. If you've got megaliters, this one is mega, and then we've got kiloliters, we've got liters, we've got milliliters. So if we convert megaliters, okay, so we know that this one, for actually megaliters, it's when we've got those companies that are actually providing water to the municipalities, okay, like rent water and mahalis and so on. Okay, so when they provide water to the municipalities, they actually do it in megaliters. And then we've got municipalities that are actually providing water to their houses. Obviously, they're using kiloliters. Okay, and then obviously in our houses we actually consume waters in the form of liters, but the municipality will only be interested in kiloliters that we are using. And then the mahalisi rent water, they will only be concerned about the megaliters. Okay, so for megaliter to a kiloliter, we multiply by 1,000, and from a kiloliter to a liter, we multiply by 1,000. From a liter to a milliliters, we multiply 1,000, and then the other way around, it's division. Okay, this is what you need to know as well, boys and girls. Conversion factor with regard to time, again, we need to know that 1 minute is equals to 60 seconds. So if you convert from minutes to seconds, you multiply by 60. You've got 1 hour, which is equals to 60 minutes. If you convert from an hour to minutes, you multiply by 60, and then other way around is division. 1 day is 24 hours, 1 week is 7 days. If it's a normal week, usually I would say if it's a school week, we know that it's actually 5 days. And then we've got 1 month. 1 month, it's about 4 weeks. It might be 4 weeks and some few days, but we estimate it to be 4 weeks. A normal year is 365 years. 1 year is equals to 365. No, 1 year is equals to 365 days. Sorry, not 365 years. 1 year is equals to 365 days, which again is the same as 52 weeks. And then in terms of a year, a leap year is 366. A decade is, we are talking about 10 years. And then a century, we are talking about 100 years. Okay, and then again, with regard to time, speed, and distance, okay, we also spoke about changing the formula. Okay, remember, in some cases, the examiner might give you a formula like this one. They say distance, it's equals to speed multiplied by time. Okay, speed is equals to speed, distance is equals to speed multiplied by, but they ask you to calculate the speed, or they ask you to calculate time. So it means you can't use this formula. You'll have to change it. That is why we've got this triangle. This triangle means if you've got a distance, if you have to calculate the distance, the speed and time must be multiplied. If you have to calculate time, then it must be distance over speed. That means you take distance, you divide it by speed. If you have to calculate speed, it means the d must be on top and then the t must be at the bottom. You take the distance, you divide it by time. So please check that. And especially with regard to time, we have seen in some of you, when they give you time in 2 units, let's say the time they say it's 1 hour 30 minutes, then you want to substitute 1 hour 30 minutes in here. So if it's 1 hour 30 minutes, you can't substitute 1 hour 30 minutes into or in place of time. You need to convert this and make it 1 unit. We all know that 1 hour 30 minutes is the same as 1,5 hours. So you must know how to convert it. This is the same as 1 hour plus 30 minutes. And then 30 minutes, we divide it by 60 because we convert it. Then it's going to give us 1 hour is equals to 1 hour plus 0,5. So that is how we get it. We say 1 hour plus 0,5, we get 1,5. So, but we saw in the past some learners trying to substitute the time in the time that has got, or the duration that has got 2 units. Please check that one. The duration or the time must only be in 1 unit. Okay, of course, conversion factor temperature, you must be able to use the formula. Okay, you must just be able to substitute and simplify. Substitute and simplify. So for this one, it's when you determine the temperature in degrees Celsius, and then the temperature is given in degree Fahrenheit. And then, or this one must be degree Fahrenheit, and then, or you need to work out the temperature in degree Fahrenheit, and then the value of degree Celsius is given. You only need to substitute and simplify. Easy marks. Yes, then I think you've got the basics now. Okay. Usually I will say that is like a checklist. It's a checklist. You check what the part of my introduction. It's actually a checklist just to check if you saw these things before, you did these things before, will you be able to do them in the examination? So that is very, very important. If you are not sure about it, it means you must still go and check your workbook, and then in your book you look for the examples, and you also look for the activities, and then maybe you can look for any previous question paper, see if you can't find a similar question, and then also try to answer it. Okay, now again, we must now be in a position where we can answer any question if you are really ready for the final examination. If you still find yourself not being able to answer some questions, it means you are not 100% ready. So typical exam question, this one, you can see that it's very familiar. It's the question paper that you wrote during prelim. It's the Gauteng prelim paper, and this was question 1. So Mr. Sweetmilk's wife bakes homemade all-bran rusk for her family. The recipe that she uses is shown below. Study the recipe alongside and answer the questions that follow. 1.1. Okay, 1.1 is how many grams of all-bran wheat flakes are needed for this recipe? Boys and girls, I always say question 1 consists of the easiest questions that you can get across the question paper. It's the easiest questions. So you can see this was taken from question 1. It should be very, very easy. Okay, but don't take it for granted, because we want you to get all the easiest questions correct, so that when you get to the challenging questions, you have already gathered enough marks. Those questions that you think are very, very easy, make sure that you get all of them correct. By the time you get to the challenging questions, at least you've got your 30%. How many grams of all-bran wheat flakes are needed for this recipe? Then let's go to our recipe and check. We've got, there it is, 240 grams. You just write it down. You don't do any calculations. No calculations. It's just a matter of writing down the answer. 240 grams. It's just 240, that's all. No calculations. And then this one is 1.2. Each batch of rusk needs to be baked for 5 minutes. The last batch was taken out at the time indicated on the watch alongside. Convert 55 minutes to hours. I also indicated the basic conversion factors in my introduction. So you should know that if I want to convert from minutes to hours, okay, the conversion factor there is 60. Am I going to divide or am I going to multiply? So if it's 1 hour, which is equals to 60 minutes, so it means if I convert from hours to minutes, I must get a big value. But in this case, If I convert from minutes to hours, I must get a smaller value. So what I'm going to do in this case is I'm going to divide. We take 55, now we divide it by 60, and then please make use of your calculator. 55 divided by 60, the answer is 0.91. I'm getting 0.916, 6, and so on and so on. Okay, now to show that you understand your math, this will be the original answer. Then you can just indicate to the examiner that you know how to round off. If you round off to one decimal place, it's going to be 0.9, because the examiner didn't specify the rounding here. If you round it off, it's going to be rounded off to one decimal place, it's going to be 0.9. If you round it off to two decimal places, it's going to be 0.92. Okay, if you round it off to three decimal places, it's going to be 0.917. So there isn't actually a mark for rounding in this case, but make sure that when you round off correctly. Okay, then this one is Mr. Sweet Milk, still the same information. The last batch was taken out of, and then the question is write down the type of time format displayed. Okay, we saw this one. Most of you in the prelim wrote a 12-hour format. You wrote 12-hour format. I don't know why most of you wrote 12-hour format, because this type of a clock cannot tell if this is 12-hour format or is 24-hour format. Okay, it cannot tell whether this is 12-hour format or 24-hour format. What the examiner was looking for in this case was just you have to tell whether this is analog or is digital. This was analog or digital. So if you look at this is actually analog. This was the answer that the examiner was looking for. The correct answer here is analog. Now, let me explain this. If you've got time and then they say the time must be in 24-hour format. Now, I've already given the answer. The answer in this case is analog. This is the correct answer. But it looks like some of you are still confused about the 24-hour format and the 24-hour format and the 12-hour format. And then the 12-hour format. Okay, now for 24-hour format, if we start the day, actually after midnight. Okay, after midnight, from midnight, when it says 1 minute past 12 after midnight, that is a new day. Okay, then you will see that it will say 000. So this will be 000. This will be midnight. And then from 1 minute past. Okay, so it's actually the beginning of the new day. Then we're going to have 1 minute past midnight, or 1 minute past 12. Then you're going to head past 1. So you get 1, you've got, let's say, 10 past, and you've got 10 past 2. You're going to have 2 o'clock, and so on and so on. Then up until midday. When you get to midday, it's now going to show 12 o'clock. So it means it's midday. If we are now using, okay, it's going to be 12 o'clock midday. If we are now using a 24-hour format, from 12 is now going to be 13. But when you say 13, you can't now say 13 p.m. because this 13 already indicates that it's 1 o'clock in the afternoon. Then you are going to have 14. You are going to have 16, 17, 18, 19, 20, 21, and so on. That will be a 24-hour format. But when we get to a 12-hour format, it's where from this one is 12, and then when we go to 1 o'clock, it's still going to indicate 01. But for 01, it's going to be 01, but it's going to be PM. So with 12-hour format, when we indicate the time for 12-hour format, we actually have to indicate whether this is AM or PM. We have to indicate whether this is AM or PM. If it's 6 o'clock in the morning, then I have to indicate that it's 6 o'clock in the morning, AM, right? And then if it's 6 o'clock in the evening, I have to indicate 6 o'clock and then it's PM. So this will be a 12-hour format. But if I have to indicate 24-hour format, this will not be 6 o'clock PM. I'm just going to indicate 1800. Then 1800, do I have to show whether it's PM or AM? 1800 already tells me that this is 6 o'clock in the evening. So you need to check the difference between the 24-hour format and the 12-hour format also. But remember, now the format can actually be indicated on a digital watch, okay? Only on a digital, that is where we can be able to indicate. But on the analog, we can tell whether this is AM or PM. Okay, so please go and look at that, especially the difference of the 12-hour format and the 24-hour format. Very, very important, boys and girls. Okay, then this one is 1.4. They say write down the time indicated on the watch in 24-hour format. Write down the time indicated. The time that is indicated here, it's nearly 1/2 past. Okay, so this is 4:30. Okay, so this is 1/2 past. This is 04:30. So in 24-hour format, it might be slightly 04:31, but it's nearly 04:30. If we say in 24-hour format, so this will only be 04:30, or it can be 16:30. Okay, 16:30. But if it was 12-hour format, it was going to be either 04:30 AM or 04:30 PM. That will be the 12-hour format. But in this case, the 24-hour format is 04:30 and 16:30. It might be 4:30 in the morning or 4:30 in the afternoon, because the examiner did not indicate whether this was in the afternoon. I'm not sure if I'm missing that, but the examiner did not indicate anywhere whether this was in the afternoon or in the evening. But it can either be this one or the other one. Okay, then this was also taken from the Gauteng province. It's due to the increase in the size of his family, Mr. Masinya decided to purchase a bigger Giza. The family purchased a 200-liter Giza, twice the size of their old Giza. So this is a new Giza. It's now bigger than the other one. Then they say it's twice the size of their old Giza. A table showing the dimensions of standard horizontal round Giza is shown below. Then the standard, there you've got the 50-liter. They show that it's a diameter multiplied by length. It means the diameter is 450 and the length is 610 millimeters. The 101, the diameter is 500 millimeters, and then the length is 840 millimeters, and so on and so on. You've got 250, the diameter is 550, and then the height is 1875. These are the dimensions which are given. Then they say write down the dimensions of the old Giza. Okay, so what is we need to figure out what was the capacity of the old Giza. They say the new one is 200, which is 2 times. So 2 times what will give us 200? 2 times 100 will give us 200. So the old one was 100 liters. So the dimensions are 550 millimeters, 550 millimeters by 840 millimeters. Okay, it was just a matter of indicating that the diameter is 550 millimeters and then the length is 840 millimeters. This was the old one, not the new one, but the old one. Write down the dimensions of the old Giza. All right, and then the next question, which is still based on the very same information, is 2.2. I don't have to read this again, but it's 2.2. They say calculate the circumference of the base of the new Giza. Then the formula is given there. Circumference is equals to pi multiplied by diameter. Okay, circumference is equals to pi multiplied by diameter. Of course, we know the value of pi, which is 3,142, but now we have to check the diameter. The new Giza is 200 liters, and they have clearly indicated that the diameter is still 550. So the diameter is 550. So this one, we just need to substitute the diameter. The examiner doesn't specify the unit, so it means we can just take our diameter as is. So we say C equals to 3,142 multiplied by 550 millimeters. Okay, we don't necessarily have to indicate the unit there. 3,142 multiplied by 550. Then this one I get 1728. 1728, and this is millimeters. Okay, so area of the new Giza will also be twice of the old Giza. Right? So what do we do in this case? So it means at the end, we need to compare the surface areas. We need to compare the surface areas. So we can calculate the surface area of the old one. So the old Giza, okay, the old one, surface area is, the formula is 2 times pi times radius squared. I'm just going to indicate r squared. Then this is the first part, and then plus 2 times pi times radius times length, the second part. Then I can just do the substitution. Let us make sure that we substitute correctly. Do we know the value of pi? Yes, we know the value of pi, which is 3,142. Do we know the value of the radius according to the way the formula is given? The old one it's 100 liters. So we need to check this. So the diameter is 550. Then you need to be careful, because in this case we need to substitute the radius. We must take 550 divided by 2. This is the radius. We take the diameter, we divide it by 2, and then I think we must get 225. 550, you can check with your calculator. 550 divided by 2, then we get, 275. Okay, you see it's very important to check. 275. 275. So 550 divided by 2, we get 275. Then we know the value of R. Do we know the value of R in this case? Do you know the value of L? Yes. Let us do the substitution. 2, and then you say 3,142 times 275 squared. That is the first part. And plus 2 times 3,142. And then it's times the radius again, 275. And then it's times, let's see, that is 840. Okay. Now, boys and girls, there is no hurry. There's no hurry. Please take everything step by step so that you avoid making mistakes. For this one, you can simplify each part. If I simplify the first part, where I say 2 times 3.142 times 275 squared. Let me see what I'm getting. I'm getting 4,7,522,7.5. Then I'll say plus. So this one is 1, 2, 3, 4, 5. So I'm getting 475,227.5. The second part is 2 times 3.142 times 275 times 840. Then I'm getting 1451604. Okay, so I'm getting 100 and so it's 1 2 3 4 5 6. So it's actually 1,451,605. Okay, so 1,451,604. Then I just add it with 475,227.5. Then in the end I get 919,26831.5. Let's see how much is this. 1 2 3 4 5 6. 1,926,831.5. This is millimeter squared. This is the old Giza. Okay, now the new Giza, which is 200. So let's look at the new Giza. Unfortunately, on that side, I don't have space. The new one, I'm still going to use the very same formula. Surface area equals to, okay, I don't necessarily have to rewrite the formula. I can just go straight to the substitution. If I look at the first part, it says 2 multiplied by 3,142, then multiply by our radius. Let us look at the 200 liter. Our radius is still 275 because it's 550 divided by 2. I don't have to show that calculation again. So it's still 275 squared, and then it's plus. The second part is 2 times 3,142 times 275. So the difference now is the length. The length is 1470. If I calculate each part, I'm going to have, please use your calculator as well, because most of you actually did not do well in this question. So it's 2 times 3.142 times 275 squared, and then I'm still getting the same as the other one, 475,227, and then is plus 0.5, and then now is plus 2 times 3,142 times 275, and then times 1470, 1470, and then this time I'm getting 2,540,307. So this is 1 2 3 4 5 6 2,540,307. Then now I can just add plus 47522 47522.7.5, and then I'm getting 3. We calculated the surface area of the old Giza, and we have also calculated the surface area of the new Giza. Verify whether his claim is correct. What is he saying? He's saying the new Giza has twice the volume of the old Giza. That is the information. The surface area of the new Giza will also be twice that of the old one. So what does this mean? It means we've got the new one, which is bigger than the old one. So it means if we take the old one, we multiply it by 2, it must give us the same answer as the one of the new Giza, because they say the new Giza, the surface area will also be twice of the old one. So if I take the old one, unfortunately I don't have space, but we can just do it here. I hope you'll be able to see it. If I take it and multiply by 2, if I take 19, I'm going to write it here, 1926831.5. if I multiply it by 2, so 1926831 So which is 1, 2, 3, 4, 5, 6. So it's 1,926,831.5. And then I multiply it by 2. I'm getting 385. So now I'm getting 3, 8, 5, 3, 6, 6, 3. 1, 2, 3, 4, 5, 6. I'm getting 3,853,663. So while this one is 1, 2, 3, 4, 5, 6 is 3,015,534. So it's actually not twice, but it's actually more than twice. Okay, it's a little bit more than twice. So verify whether his claim the surface area of the new Giza will also be twice. When he says it will also be twice, it means when I take the volume of or the surface area of the old one, I multiply it by 2, I must get exactly the same answer. But in this case, I'm not getting the same answer. So verify whether his claim is correct. His claim is actually not correct, because it is more than twice. It is more than twice. Okay, so it is more than twice. So that is how we did the calculations. So what the examiner was trying to show us in this case is, if the volume is twice, does not necessarily mean the surface area will also be twice. Okay, so that is what the examiner was trying to indicate in this case. Okay, so the next question, it's Mr. Masinya wanted to be sure that the stated capacity of the Giza is correct, so he performed the following calculations. This was a very interesting question. This was a very interesting question. Then most of you were not even sure how to approach it. If I were you, what I was going to do, if I know my math lit very well, I would just about everything. So what you do, you just imagine as if that answer is not given, and then you work out your own answer without looking at what start by calculating volume. If I have to calculate volume, this is a cylinder, pi r squared h. So how do I calculate it? Now, in this case, first thing that is important, you have to look at the conversion factor. The conversion factor will make it easier for you. In the end, the volume, if you look at the conversion factor, if our volume has to be in centimeter cubed, then we'll easily be able to convert it to liters. If our volume will be in centimeter cubed, and then we'll easily be able to convert it to liters if we have to. Okay, so in this case, what we're going to do is we say, right, our pi is 3,142. Okay, and then our radius is what? Our radius is, we look at, Mr. Masai wanted to be sure that the stated capacity of the Giza is correct, so he performed the following. Okay, this is for the old one. This is for the old one. So the old one, it's 275. So we say 275 squared, and then we say the height in this case will be the same as the length. So the length is 840. Think about this. When the Giza is upright, obviously that is the height. When it's sideways, is the length, but they are actually referring to the same thing. That doesn't change the value. So this will be 840 squared. Remember, the 275 and the 840 are in millimeters. They are in millimeters. So if the radius and the height are in millimeters, what does that mean? It means our answer is going to be in millimeter cubed. What is important here is our radius and the height must be in the same unit. Okay, then we say, if I simplify this, I say 3,142, and then I say open bracket 275, close the bracket, I square it, and then open bracket that is 840, then close the bracket. Then the answer that I'm getting is, okay, I'm getting 3,142, and then I'm getting 1, let me see, 1, 2, 3, 4, 5, 6. I'm getting 199,000. 199,000. Let me see if I did everything correctly. 275 squared, 275 squared multiplied by 840, and then multiply by 3,142 is, double checked, 199,595, 199,595, and then after 595 I get 550. 550. Remember, this will be in millimeter cubed. Why is it in millimeter cubed? Because the radius and the height are in millimeters. Okay, I've got 1, 2, 3, 4, 5, 699 million, and then it's millimeter cubed. Okay, now I need to convert. The conversion factor that is given there is centimeter cubed. The question is, how do I convert from millimeter cubed to centimeter cubed? Is from millimeter cubed to centimeter cubed. Let us look at this, boys and girls. We all know that 1 centimeter is equals to 10 millimeters. And most of you are using the very same factor. If they say convert millimeter cubed to centimeter cubed, most of you will still divide by 10 because you think they're the same. This is actually for the length, it's not for the volume. But now, if you have to convert from a millimeter cube to a centimeter cube, how do you do that? It means you need to know the conversion factor. If it's 1 centimeter cubed, it simply means if I take this and make it to the power of 3, this is going to give me 1 centimeter cubed is equals to, what about 10 to the power of 3? 10 to the power of 3 will give me 1,000. Then millimeter cubed. So what does this mean? It means if I convert from a centimeter cube to a millimeter cube, I have to multiply by 1,000. But if I have to convert from 1,000, if I have to convert from millimeter cubed to centimeter cubed, I'm going to divide by 1,000. So therefore, for this one, I divide it by 1,000. Then after dividing by 1,000, it now becomes centimeter cubed. So it must be 199,595,55. It's now centimeter cubed. I have divided by 1,000 to get it to centimeter cubed. Okay, now I have to continue. I have to convert it to liters. Look at the conversion factor. 1,000 centimeter cube is equals to liters. That means if I want to convert from centimeter cube to liters, I have to divide by 1,000, because from centimeter cubed it changes to 1. You can only get 1 there by dividing by 1,000. If I want to convert from liters to cubic centimeters, I'll multiply by 1,000. So it means I have to take this and divide it by 1,000 further. So I'm going to write it here. 1, so volume is equals to 1, 9, 1, 2, 3, 4, 5. So I've got 199,595, 5 centimeter cubed, and then we divide it by 1,000. Okay, it's a very tricky one, especially because we are working with big numbers as well. And then, boys and girls, you need to be careful. Working with big numbers, it's also not easy. So you need to be careful. So we divided by 1,000 further. So when we divide it by 1,000, I get 199,595, and then it's now liters. It is now liters. we can still round it off, and then if you round it off, it's about 200 liters. This will be the correct answer without even looking at the solution. We know that in the end, we have to have this in liters. Now we go and check what is wrong with this. How come this one is not the same as ours? We can check that in this case, the substitution, starting from the substitution, they have substituted 550 in the place of radius. Okay, but this 550 is actually a diameter. So we can say diameter was not converted to radius, or diameter was substituted into the space of radius. Okay, so that will be the first mistake, and then they got the answer. And then they still saw 79,827,869,33. Can you see that this one and this answers are the same, but they have changed the unit? They have just changed the unit without dividing. So we can say this one, they did not divide by 1000 to get 2 centimeter cubed. They were supposed to divide by 1000 to get 2 centimeter cubed. And then with regard to the final answer, converting to liters, yes, they divided by 1000. So 2 mistakes here. It's diameter was not converted. Diameter was not converted to radius. And then millimeter cubed was not divided by 1000. Was not divided by 1000. Was not divided by 1000 to convert to cubic centimeters. Okay, sorry, I don't have enough space there. But the first point is diameter was not converted to radius. And also the second point, when they converted from millimeter cube, or when they changed the millimeter cube to centimeter cube, they should have divided by 1000, of which they did not. That is the mistake there. But you could only be able to fix here. It's 1000 is supposed to be 1000 cubic centimeters. I think we have already answered this question. Radius is still 275, so it's 3,142. Okay, 3,142, and then it's open bracket 275 squared, and then open bracket for the length. The length is 1470. Okay, if you want to substitute the unit, you're welcome to substitute the unit. But for me, whether you indicate the unit or not does not matter. Okay, so this is 3,142,2755 squared, and then open bracket. Then you can just use your calculator. If you are sure about everything, you can just key in 275. I usually start with the square. I square the reason why I start with the square is because most of you forget the square. So I'll start by saying 275 squared, and then it's times 1470. So 275 squared times 1470, and then times 3,142. Okay, so I'm getting a very big number. Okay, so I'm getting 929. I'm getting 2212.5. And remember, the radius and the length were in millimeters. So this is millimeter cubed. What is this number? 1, 2, 3, 4, 5, 6. I'm getting 349,292,212.5. It's very, very, very big number. The examiner might ask you to write it in weights. So 349,292,212 212.5 millimeter cubed. Okay, but in order to do the conversion to liters up by 1000, if I divide this by 1000, divide by 1000, and then I'm getting 3, round off your answer to the nearest liters. It means this must be in liters. So what I say is I divide it further by 1000, then I get 349,292,2125, and then it's now liters. Then this is 350. Okay, so the capacity according to the given information is 350. So it's 1470 multiplied by 275 squared and times 3.142 is. So in the end, I get 350 liters. Okay, now from the 350 liters to the nearest liters. Okay, of course, we did to the nearest liters, which is 350. Okay, then 2.6, they say, should Mr. Masinya be happy with the new Giza based on the capacity? Provide a reason to support your answer. I think in this case, Mr. Masinya will be more than happy because this is actually a bargain. When he bought it, he thought it was for 200 liters, but when we do the calculations, we can actually see that this is actually more than 200 liters. So the 200 liters becomes 350. I mean, when we do the calculations, we are getting 350 liters. Okay, so boys and girls, they are actually indicating that time is not on my side. So I actually wish that I could do more than this, but unfortunately, we are only given a limited time. But once again, please make sure that you go and practice what you are still not sure about it. Okay, so thank you very much for watching today's program. I hope to see you next time. All the best. Goodbye.